So this is sort of the final presentation on this main stage for ZK11. Last time for ZK10, we did something called State of ZK. And today, I mean, in a way, we're doing another one. So we're going to be looking at, like, we have a few topics that we want to cover just generally, like more kind of like higher level looking at the ZK space. I think we're going to try to reference lots of talks that actually happened today. If you've already been in this room, I think you all know that the mics near you could be used. Actually, maybe you can let them know that we should turn on the mics now. They're on, right? Yeah. Perfect. So I want to try to make this a bit interactive as well, so I'll kind of throw to you guys if you have questions. Even if I'm not asking, if you have some point about what we're talking about and really want to join in, just put up your hand so I spot you. And then when there's a break, I'll let you ask the question. So why don't we introduce ourselves to start? I'm Anna. I'm the host of the Zero Knowledge podcast. I'm one of the people who puts together the ZK Summit. I also have a company called the ZK Validator, or actually now we're just going to ZKV, and I also have a project called ZK Hack.
I'm Nico. I am a cryptography researcher at Geometry Research, and occasionally a co-host on the Zero Knowledge podcast.
My name is Georgios. I'm the CTO and a research partner at Paradigm. I've worked for a few years in crypto, infrastructure, application development, and Zero Knowledge, and most recently I've been building the Foundry and the Reth project.
Hi, everyone. I'm Alex Evans, one of the partners at Bain Capital Crypto. On occasion, they let me loose from investing and let me come to some interesting conferences like this. In this occasion, I'm channeling my friend and colleague, Guillermo Angeres, who couldn't be here. And I am sometimes allowed to come on the ZK podcast when they don't have other guests to talk to.
I want to ask all of you, what was the first ZK Summit that you ever went to? Alex?
Oh, this is embarrassing. I'm going to get destroyed by these people here.
9?
What was the one in Lisbon? Was it 9?
9, yeah.
Yeah, it was 9.
Okay.
You were at the first one, weren't you?
I attended the first ZK Summit in Berlin in 2018. Didn't know many people at the time, and big shout out to Anna for bringing this great community together.
Has it changed?
Never changed.
Okay.
I think my first one was Amsterdam, which would have been 7? Yeah.
Well, one thing has changed. There's more people, more exciting work, and now you have side events.
Yeah, that's true, yeah. All right, so we have a list of things that we wanted to cover. Starting point was, so I wanted to talk about some of the infrastructure that's being built and talk about the sort of server-side, client-side divide. I think there's, like, using the term ZK and what it's even for sometimes is determined by whether you're working on the server side or the client side. So let's define this for folks and then talk a little bit about how the infrastructure for these things are different. And also if we can maybe mention some projects or teams that are working on either one of these to help people kind of, place that.
I have a simple way to think about it. That is that client side optimizes for latency, whereas server side optimizes for throughput. And client side enables privacy, whereas server side, it's harder to do without leaking most of your privacy, although there are strides to solve that with partial witness generation locally.
But if client side if server side is not, it's harder to do privacy, what is the benefit? Like what kind of are they optimizing for there?
Server side is traditionally used in high-performance compute settings like ZK rollups, where you have the benefit of receiving a big amount of transactions, aggregate them, recurse, batch, compose on a big machine, hundreds of gigabytes of RAM, hundreds of cores, hardware, which we might touch on later, and that allows you to get really high performance in the ZK rollups. Whereas for client side, what you would expect is, I have my mobile phone and I'm authing into a service and I don't want to leak my passport information.
Yeah, I think that final one is a very pertinent one. You utilize recursion extensively in those settings versus straight line proving seems to matter a lot more in client-side settings. Now, that said, proof systems are still bound typically at the leave, so in both cases, when you have ZK rollups, the straight line performance ends up mattering a lot. But you could expect as that changes and you get faster provers, that straight line proving for a single proof on the client side, that's going to be always bottlenecked. And recursion and how cheaply you can do large-scale recursion is going to matter a lot more forever in the high-performance setting.
No, I think that's all fair. You can also sort of combine both. So systems like Aztec, for example, where you want users to have privacy, but also the system to run fast, you'll have sort of a private local client-side proof, and then that gets pushed up to a server, and then you can deal with sort of the state of the bigger system, right? But the divide, kind of only exists because computing proofs is expensive, and server side, why do we bother putting provers on a server? Just because that's more powerful. That's it.
I also think the divide between client-side and server-side proving is going to go away as you get into collaborative proving networks, where effectively every server is also a client because they need to pass on the proof to someone to continue proving the statement.
It seems in general to me, and this might be wrong, that the client-side applications of ZK, especially put in the framework of privacy and the like, have seen relatively less adoption and interest. Where we see a lot of use, a lot of funding, a lot of excitement is more server side. And it seems to be potentially performance related, or maybe it's an inherent quality. If you look at history of computing, you see mainframes and things happening in the enterprise before you saw personal computing decades later. So maybe that's just a general trend, as things start out centralized where you need efficiencies of scale, and then move out to the edges when client-side anything, personal devices get performant enough to use the system? Or do we think it is inherent to the applications?
It's a bit, one aspect of it is performance. I don't think it's that simple. I think it also has to do with managing private state, managing the interaction of private-public state, the ledgers. We don't have Henry from Penumbra with us, but he talks about that a lot. How you really need to build privacy in almost by default the base layer, and you need to think about it everywhere, because otherwise you're building castles made of sand.
The ZK and ZK snarks, does that only exist on the client side? We just said that, right? It's like privacy usually lives there, and snarks can be used everywhere, or starks, or these combination things, and whatever they're going to be called in the future. But yeah, the ZK part, is it usually lost on server side?
You don't have to lose it, but sort of the nature of server-side work is I, as someone with low computational power, is going to send my data to these people with high computational power. So kind of by default, I'm already revealing my data to this service. So with that regard, ZK, it's over already, right? So you don't need the ZK. The other thing is the kind of applications we're using them for. So if you're just looking for succinctness, so one machine that takes a bunch of transactions, rolls them up, you don't need the ZK part. So it's kind of like the nature of the tasks that we push onto server-side proving don't require ZK, really. I do want to say, there is kind of an in-between. Systems like ZK SAS or other proving delegation mechanisms, where you kind of hide your secret data, send it off to be proven, and then it all happens server-side. So you kind of get the best of both worlds with those systems.
I just want to sort of throw it, I'm actually going to shift a little bit gears, but if anyone has any thoughts or wants to add anything from the audience, let me know. I'm going to do this kind of after every topic that we cover, I think. Okay. Do you have a mic near you? Just make sure the red button is on. Oh, someone next to you just passed it.
Yeah. 1, 2, 1, 2. Yeah, it works. Yeah. I think client-side proving is extremely interesting. You were saying, sorry, I forget all names. But
Alex?
You.
Alex.
Alex, yeah. You were saying that client-side proving is not used. It's used already a little bit. Personally, I work for Maiden, Polygon Maiden, so we do client-side proving. Yes, we're not live yet. Aztec uses it. WorldCoin uses it a lot, generating like millions of proofs. And so I think this is going to be something very, very big. And this is going to be a next step, like a next iteration on our way there. And one thing that I'm also going to talk about tomorrow, but I think it's very, very interesting on client-side proving, is that client-side proving can really be a revolution because it brings many, many properties. The first one that we've been talking about is privacy. So you have privacy when you generate your proofs client-side. But another thing is also that you have hyper-scalability because you push like all the computation to the edges. And so now like all your computation is like, just your rollup can be way, way lighter, and you can make way like a way larger amount of compute just on your rollup, and so it can be like just.
I agree with this. I think the abstract is valid. I think the concrete is going to be more interesting to observe because when you modularize a system, you introduce bandwidth, you introduce communication overheads. And these are not necessarily navigable versus the more big machine. So
I agree. We've talked a little bit about that on Twitter, actually.
Pardon?
We talked a little bit about that on Twitter, actually.
Oh, I forgot.
Yeah, but yeah, I agree, and I'm very curious too, and that's why I think we push it forward because we really want to see these systems in production. Yeah. And so that's our goal personally for Maiden. Our goal is next year. I also think that Aztec is going to come out pretty soon. And so, yeah, I think that's going to be something very big when we see all these systems in production and we can actually benchmark it against like actual systems that we have right now.
Totally.
I think it's going to be super interesting.
I want to add to that. So you just mentioned a few projects. I think Mina also falls under that category of client side. Is there anyone else that's doing client side that you can think of? Is Alio doing client side?
I mean,
I think so.
Yeah, and most anybody that's working in and around identity.
Okay.
Right, so a lot of the attestations that people are doing, things like WorldCoin and the like, would be using client side even more so long term. I think my bigger question is, and this is related to what George just was talking about, is, okay, let's say you have the performance. Let's say the latency is really low and it's beautiful to use it. This isn't like you can just throw it out into the world type of thing and like Steve Jobs, whatever, your fingers are going to get used to it. You have to think about the design of privacy-based systems very carefully. State management is a classic example of this. And again, shout out Henry from Penumbra, who's very thoughtful on this point. It's like so unintuitive for the user. It's not like other technology. If you expose the wrong bit somewhere and then like everything about you is de-anonymized all of a sudden, and you have no privacy where you thought you had all privacy, that sort of stuff is very counterintuitive. And we're going to have to think about how do we actually design, like let's say the performance is there, and right now we need to work on that, people are working on that. How are you going to make systems that are actually usable, that take advantage of privacy on the client side?
To give a very concrete example, like wallets, they are not great, and they don't manage any state. So you're telling me that we're gonna require that the wallet is an online client, it downloads proofs, it like executes everything locally, then it manages all that state, sends it back. We need new people.
You can hardly manage key infrastructure.
Yeah.
Is a coprocessor client side or server side?
Labels are for products.
Nice.
Okay, well, like the standard. Is Axiom server side or?
Those would be server side, yeah.
Server side?
Yeah,
okay.
Axiom proofs are big machine, yeah.
Yeah, I was just going to add one thing. So it's way less cool than privacy, but as ZK becomes mainstream and the actual computation costs grow that we're seeing in the world, then you may get this traditional boring business case argument for client side, which is that it actually decentralizes the compute cost. So if you're a company and like you could process stuff centrally and pay for it all yourself, or send it over to your users and get them to process it locally for you, then that might be an argument for client side.
I think that it kind of echoes what you were saying about pushing computation to the edges. I do want to push back a bit against that because we're pushing to edges that have very low computational power. Like that is why we have servers that sort of centralize computational power. It's to avoid having to do all our work on these things because I can't. So I don't know if that's fully realizable, at least not without like a big shift in how we use sort of big computational systems.
Basically, blanket statements of the sort of, I modularized the stack and now it's faster, are misleading and they should be evaluated in like concrete. Because anytime I have a bundle and I open it, like, yeah, I can spend less compute because I can optimize each system independently, but I also impose myself a coordination cost of any kind, again, in the very abstract, and it's not obvious that the sum is less than the whole, cost-wise. Like, just one more infra layer, bro.
Yeah, and we'll solve everything. This is like the classic thing too with GPU, like GPU networks and the like. It's just everything where it's just like, oh, we're just going to push all this work to all this spare capacity. It's like, okay, and now you need to send it somewhere else. It's like there's a reason these types of workloads happen in an integrated manner in a data center, for example.
You have to press the red button.
Hey. Yeah, so I just wanted to add pay to that. We do client-side proving already on a phone, and it's 1 second for the proof generation.
This is a no-shill space.
Oh, sorry,
I should have told
what?
you.
No one said that?
But totally cool to add your name to the list.
No, but yeah, I just want to, and I wanted to actually concur with the point. Like, actually, one of the biggest challenges we had when we built that was not only do we have to protect the private key, we have to protect the data, and we have to basically think whenever you do a transaction, we have to be really careful because if you lose that data, you can't spend that money anymore. And so, like, the backup process like took us so much work and making it privacy preserving but also secure and backed up. So yeah, I agree, like there's a lot to think about in that space. And sorry.
No problem.
1 second is fantastic. If you're in spinner UX neighborhood, like you're good. If you're in the loading bar, it gets a bit messy.
Go make a coffee, come back, check it later.
Yeah.
Not going to work.
Hi, can you hear me? I wanted to ask something about server-side proving that you mentioned earlier. So do you have any opinions on collaborative snarks that maybe can solve this problem when you say you lose the ZK part when you're doing server-side proving?
I think, yeah, those are in principle great. I really want to see more people develop that and push into that. I'm not sure what the barriers are. I guess the main one being incentives, like why would I bother proving your stuff? But yeah, I think there's been a lot of talks today about prover markets, so that sort of fits into the same regime.
And again, cost of coordination, doing a collaborative snark, is there an MPC or a consensus over the snark? Overheads, what does that mean downstream? So yeah, again, good ideas, the concretes will matter a lot.
How much is Nico, have you looked at these? What is the additional overhead for those?
Not sure, not off the top of my head. But I mean, the overhead is worth it, right? Like, I don't care that it is less efficient. We're unlocking this ability of proofs that I couldn't do on my phone. I can now offload privately to someone else. So as long as they have the right incentives, I don't care that it's lower for them, right? I think even ZK SaaS have results where they manage to distribute the load in a way where the like wall clock time is actually shorter than if you were doing it on one device.
There was a great paper or set of papers by Alex Ozdemir on this, which was really exciting, where you can basically do, you can apply it for order matching indexes. I believe the Renegade project pursues this, where, you know, Alex has a bunch of orders locally, I have a bunch of orders locally. I don't have privacy with my customers necessarily, but if I want to do order matching with the order flow that Alex has received, we can effectively match them over an MPC protocol. And in the process of running this MPC protocol, the thing that gets produced in the end is the match, which is a snark, and then I take that snark on chain. So that's also a useful tool in the toolkit to know.
Interesting. I actually want to move us to another topic, which I just sort of touched on briefly, which is the coprocessor topic. In the last year, I think it's been a little over a year, there's been so many projects that have launched or announced, and they are a coprocessor of some kind. I think more recently we're seeing some of them specializing, so they're like a something coprocessor or a coprocessor just like not general. But what is our take on coprocessors? Because I feel like there's still been a question mark about like product market fit. Like
Should we define?
Okay, yeah. Why don't we start there? So let's define
because
a coprocessor.
again, I think crypto has a jargon problem,
Oh, yeah.
and we like to reinvent terms, and we like to reinvent technologies, where instead, just use the term. So a coprocessor is two things. Well, I have Ethereum, slow. I want to offload compute and verify it back. I can do that either on Ethereum or elsewhere. What does that decompose do? It decomposes to a jobs API, like your standard subscription, where you submit a job, you get an ID back, you poll it or you get a notification, and then you check that the request completed. And the other thing that it requires is a verification. So a coprocessor does not necessarily mean a certain kind of thing. It can mean any kind of offloaded compute. A rollup is a coprocessor. It's a very heavy one. In practice, everybody is doing application-specific coprocessors, and some choose to route the input function of that coprocessor to Ethereum L1, and that means that you need to verify state roots and state proofs against that. But beyond that, the compute that you run, it could be anything. And yeah, I've always found the term a bit of a misnomer, almost.
But maybe the distinguishing factor for the question, I'd be curious how you define it, is the rollup will persist state between runs of the quote-unquote processor or whatever, the process that you're trying to run, versus there's this more general thing that need not, right? And the question is, okay, we definitely all presumably believe that there are applications for rollups. Do we believe that there's additional applications that you gain from that additional generality that you imposed?
Yeah, specialization drives performance.
So other than specific things, such as I want to compute non-native cryptographic operations and so forth, what are the ones you're most excited about?
Actually, I'll take it.
I have an answer. Justin Drake talked about this in the morning. I think opening storage proofs across rollups. Wait, was it this morning? It was. Well, opening storage proofs across rollups is a form of coprocessor style operation, and it unlocks composing state safely between rollups. So for me, that's a very exciting use case. I also think that you can use coprocessors, again, to create a primitive that broadcasts one-to-many chains. This can break down the chain link monopoly, where you can have an oracle value that went to one chain and you can rebroadcast it to every other chain. Like the crazy person would tell you that we can do big machine learning operations at scale, but I think we're quite far from that.
Were you going to say that?
No, you pretty much covered the cases. Yeah.
What about the, because there was this boom of coprocessor teams, another question that came up was sort of like, how do those projects actually make money from fees or launch a token or do something? Are they going to have to shift gear in a way to eventually become a business? Or have some of those teams actually found a case where it works as is? I don't know if you guys are looking that closely at these, but that's been a question of mine.
Yeah.
So is the question, what is the value capture strategy for coprocessor companies?
Yes. Do you know?
I have a take.
Okay.
Oh, Zaki wants to take it?
Oh.
Sure.
Okay.
I mean, so the obvious sort of meta of this is token incentives, right? So right now, token incentives are very driven by these ad hoc DAO political processes, where you go and you present your spreadsheet of we encounter this with Sommelier a lot. We provide a lot of liquidity for protocols like Lido. But how do we actually incentivize our users? How do our users get rewarded? Is we take spreadsheets of data to this committee at Lido, and we go, look, we are actually effective, and our the liquidity providers in our vaults should get rewarded. The obvious thing is automating that with coprocessors, and there's actually many, many, many millions of dollars that flow over these incentive programs, and there's like an easy take rate from that.
And actually, Zaki, like that's a great point. So many times people think of coprocessor as ZK coprocessor. One can easily think of Sommelier also, or sorry, I'm mispronouncing.
We did pioneer that branding.
You have pioneered a lot of things in crypto, Zaki. We don't doubt that.
So, okay, you're saying that in that case, there is enough money flowing that you just need to take a cut of that, and that would be.
Yeah, so like, you know,
for-
let's say, I mean, I don't know what the numbers are right now, but like, let's say, you know, some protocol is doing like 100, you know, 20 to $100 million a year in like incentives. You take, you know, 1% of that as like the fee to the coprocessor for like administering all of this and making the like commitments credible, and like you've got a revenue model.
There's always the question also of, are you building a protocol? Are you being a company? Are you doing both? Are you giving the protocol out for free without a value capture mechanism on top of the protocol, and you intend to value capture on the application that you build on top of the protocol,
True.
or you have proprietary rights for introducing updates to it? It's a bit nuanced and unclear. I think token incentives that you can run on the protocol are one way, like volume-based pricing is another. If you're a server company, which you might as well be, you can charge fat SaaS on top of it. There's like many approaches, and people should try them all out.
To circle back to our definition of core processor, it's so broad, so wide. It's just like any offloaded computation that for sure the business model is also going to be super broad and super wide.
Fair. Interesting. Going from coprocessor, another field that became very popular even more recently would be the prover networks. Are they connected? Is this like, will some coprocessor projects potentially launch their own prover networks? Do you think prover networks will launch coprocessors using their prover networks? I think we've seen a few of these moving up and down.
Coprocessor will have demand for like proving, right? People will need to prove stuff if you want to do sort of a ZK or a succinct coprocessor. So there is a synergy there. If I have a coprocessor, like, yeah, sure, I'll push it into a proof market. Or if I'm building a proof market, I need demand, I'll create a coprocessor.
Yeah. Does there need to be a ZK VM between those two things? Is it actually like prover, marketplace, ZK VM, coprocessor?
Right. So it's worth zooming out and reframing the question into the same way that in the MEV world we have the transaction supply chain. And to make money in the MEV world, or in the transactions world, you want to be firstly in the critical path of the transaction supply chain, at the edges of the transaction supply chain, because that way either you monetize the user or you monetize the infra. What you observe is that the closer to the middle a player is, take in the transaction supply chain, take Alchemy, for example, where RPC is generally commodity business, you immediately see the player needs to move outwards and outwards enabled in order to sustainably capture value. The same pattern will play itself in the proof supply chain, where who owns the user? Probably the wallet again. The wallet is a very powerful place to be in to monetize any value flow in the crypto ecosystem. And downstream of that, maybe you have a VM that the application needs to use. Or well, rather, downstream of the transaction of the wallet, you have the application. The application is written with something. The something and the barrier to entry to use the something defines the demand side downstream of that. So if you use a VM, plausibly if the VM is fast enough and it's like great enough to use, that brings the barrier to entry very low, which means that even more value flows to the system. So if you're building the VM, I would think that the VM is like a hard piece of software to commoditize monetize in a vacuum.
Yeah.
And you also need to own another layer of the stack, no pun intended, which is core part of the succinct strategy, which Uma eloquently articulated earlier in the day. Downstream of that, if you have ZK value flow, then what comes after the prover marketplace? There's the hardware side. And there's interesting questions around how all of these actors play with each other. Who is friendly today becomes uncompetitive tomorrow, and so on. And I think, like being very self-aware of your positioning today is important to know how to move in the coming weeks, months, years.
The way we think about it is similar. We largely think about two things. One is, where are the reinvestment runways? Now, this is less more of an analogy to MEV and more of an analogy to computing and as it's played out. You think about at the lowest layer, companies that can reinvest the profits they generate by serving proofs to you, either participating in a prover network or administering that network or wherever, anywhere in the stack. If you get a marginal dollar of revenue and reinvest it in your infrastructure, what payoffs do you get? And for how long can you extend high ROIs in doing that? And realistically, hardware would be that at the lowest layer. At the VM layer, I agree with Georgios. There's this question of if a lot more people are using your VM, and maybe even in the beginning, while you're not a commodity, maybe you're the only one or one of three, you're getting paid, how do you go off and make that better? Historically, standards would get entrenched and they'd be proprietary. So there's not going to be in the ZK space an IBM that's going to come and enshrine x86 and say, we are all going to use that, and now everybody's going to start targeting that. And only you have control over that standard. And so the ZK VMs invariably end up needing to compete with a wider plethora of standards. And some of them will become dominant, some may not. But it seems that the open source revolution comes to that very, very fast and commoditizes it. And so then the question is the classic hourglass when value gets pulled in either side. The standard way to look at it again is on the client side, can I take the marginal customer that comes in and pays my wallet and make the experience better and better so that I keep more customers? Again, this is like Apple on the one side, NVIDIA on the other, right? But there doesn't seem to be an Intel somewhere in the middle because nobody, unless Ethereum comes in or maybe one of these and enshrines a particular ZK VM, which I don't think is going to happen, right? Then you're never going to get much value capture in the middle.
And there's something to be very present to, and I realize the conversation got very VC, that business
At your service, Georgios.
No, but like business strategy is extremely important, and I think people forget about it because we're doing like hard tech, and it's very important to be, again, very self-aware of this. And the standard business strategy concept from many years ago for software is commoditizing your complement. Because when a customer buys a thing, they also buy another thing together. When I'm buying Alchemy, I'm also buying Dune, for example, as a user, because I need both this and the other. So it's a positive strategy or a useful strategy if you are the one to give away the other for free. So if you're a prover network, it makes sense to give the ZK VM for free because that drives demand to your thing and makes people less likely that need both to use your software or your stack instead of the others. And again, it's very important to be very present to these, because if you're not, down the line, if you're building a business, that might actually hurt your culture, your strategy, your mental health, a lot of things.
That's some God tier VCing.
It's important to be honest with ourselves.
We sort of you touched on it for a moment there, but it was the hardware part of things. So we're going to move a little bit away. Well, actually, wait, maybe before I do that, does anyone want to voice anything on that part of what we just described? This is the coprocessors, the prover networks, the ZK VMs. Are there any questions or thoughts around that space? Oh, I hear
Hello.
someone. Oh.
Yeah.
Okay.
So on the call processor flow, you also mentioned MEV transaction flow. It all comes around to what the user in the end wants to do and how you can capture value there. If there's demand for attestations and there's demand for composition of statements, I think mostly about digital identity nowadays within WorldCoin, etc. You want to compose the attestations from multiple data sources, etc. There's always transaction flow there that you want, but it's just sort of a bit different. So you can also capture value in that sort of space as well, directly, sourcing your own order flow of sorts.
Yeah, that's very fun.
Yeah, that's it.
So if that's all on this front, I want to now move us over to hardware. There's been a lot of action in the last, I'd say 2 years.
We should caveat on hardware that both Alex and Paradigm, both Bain and Paradigm are co-lead investors in Olvetana, so take the takes with a grain of salt.
Nicholas, prepare a throat clearing. You're going to solo this one.
Let's go.
Kidding.
There's quite a few hardware companies, though, that are playing in the ZK space. So there's Olvetana that you just mentioned. There's Ingonyama. There's, I think there's supranational that is like...
Justin said 9 companies
Oh,
this
you
morning.
did? Okay,
about
wow,
ASICs.
I did not write those down, but there's a
Yeah.
ton of companies who are like at least exploring the
And
ZK
tomorrow,
space.
Ngonyama is also organizing a day.
In
specifically
Ngonyama,
for
yes,
that.
exactly,
Yeah.
ZK Accelerate. But what are we thinking about the hardware space generally? What is the state of it? I know Justin did do this talk earlier, and he had an example of an ASIC, but how far are we from actually using these things?
Yeah.
do you
Firstly,
think?
it's funny. Every 6 months, I get different conflicting signals. Like 6 months, no, okay, let's say a year ago, it was like, oh, it's all about FPGAs and making ASICs. And then over the course of 2-3 months, people are like, oh, no, actually, we don't need all those. GPUs are enough. And then someone comes up and says, actually, you know what, even forget that. CPUs are great. And now we're back to like ASICs all the way. Like, here's the ASIC, I've printed it. So I'm honestly not sure where to look at.
So in 2022, I wrote a post about hardware acceleration for zero-knowledge proofs, and it's worth, again,
yeah.
zooming out and reframing. So why do we need hardware in the first place? Because proofs are big, proofs are slow, and the statements are only getting bigger over time. And there's famous quotes from, 40 years ago that all you need is like 70, 68 kilobytes of memory, blah, blah, blah. And now our mobile phones have like more compute than the computers that send us to space. So I think hardware is A, needed. B, the design space is very broad. C, it's hard to make normative statements about there are only going to be ASICs or only FPGAs or only GPUs. And D, it's worth to approach it just from what is the optimal proof generation pipeline and work backwards from that. And my main take from that, just to get it a bit more technical and get out of the VC speak, is that I think actually maybe the Polygon team had published something on this, where basically the optimal proof pipeline, I feel, looks like a bunch of transactions coming in. All of these transactions, let's say I get a block of 10 transactions. All of these 10 transactions, maybe they get client-side proven, firstly. That might happen with specialized hardware that ends up running on the ASICs that Justin showed us or something else. And all of these proofs, which themselves...
You mean on the user's device, there will be hardware?
Yeah, definitely.
I see.
Yeah. Like just how there's like Apple Silicon today, and the Apple Silicon is a system on chip, which is effectively like a mini GPU. It has a neural engine inside of it. A neural engine is a mini GPU in the most literal sense. So main transaction will come in, these transactions will get aggregated, then they will be self-composed and recursed, which means that if I have this big size proof after the first snark, I can keep composing it with itself to compress a bit the size. And then there's an important thing that the final part, then if you need to verify it on chain, that needs to have a constant cost, again, in the optimal case. And the only snark that we know with constant cost in this case, I believe, is the Groth, the Flong. These two are, I think, the two snarks. Like, and you would know better. So my wager would be that you need fast proving and fast verification. Seemingly, there's a fundamental trade-off between hash-based snarks and MSM snarks, or elliptic curve snarks, because hash-based snarks have fast provers but log proofs, whereas MSM snarks have slower proofs but constant verification due to the beauty of pairings. So what this might look like is that X percentage of the time is going to be spent initially on the pipeline on fry snarks, then a bunch of self-composition, and then eventually you recurse, or you compose with a Groth or with a Flong snark, and this ends up going to chain. Now this means that there's a classic rule when you're optimizing that, if 80% of your time is spent on this part and 20% of your time is spent on this part, completely removing the 20% only gets you, what does it get you, like 5x. This might be good, but it might not be enough. So with regards to where people want to look for hardware, they should again be very present to where is time spent in the system in the current end state. And it might get spent on hash-based or elliptic curve snarks, and depending on where you are in that value chain, again, it informs also your value capture.
But I guess that's part of the point, right? If what we want is speed up hash-based snarks, we don't need special, like, ASICs. Like, our hash functions are already designed for the hardware we have. Yeah. So that's why like it's hard to figure out like
The one-liner of this, which, I could look at this like in 2 years and be like, I'm a complete idiot, would be that, MSM snarks, because they are at the end of the supply chain, and the statements are going to be like, maybe like roughly fixed, or they're not going to change a lot, maybe they admit ASICs way more than going closer to the developer, where the shape again of the statement changes more, and you need to be more dynamic with the optimal shape of the prover.
yeah.
I think more generally, wherever there's ossification in the stack, it's just saying that if we're going to do no better on proof size than Groth or Flonk or whatever, then that's always going to be the final step. And if that's the case, that's a good target. If there's other points in that pipeline where we have extreme levels of confidence to spend a year and a half, how much do these things take these days?
18 months.
18 months to tape out. So is that thing going to be totally different? Because like a year ago at the ZK Summit, we were talking about totally different proof systems on the front end and what was going to be the next thing. And there's always like a next hot thing, it feels, which is great. It means the field is moving quickly. We're taking things that are super linear, making them linear. We're shaving log factor. We're just moving breakneck speed. This isn't like we took something and sped it up 2x. We are like completely rethinking these systems.
It's like complexity level reductions.
And the ones that we haven't gotten better at is just making really small proofs, so maybe that's a good one. But if there's any other points along that spectrum that where you can be reasonably confident that you're going to get some shelf life out of your ASIC or whatever, then maybe it starts to make sense.
And another thing to be very present to, Justin showed us one chip. It's interesting to see what does industrialization of this look like. Today, there are only 2 big GPU companies, NVIDIA and then next to it, AMD. And there was a time, and we had a person from AMD here where we had a good chat about, in the 90s, there were tons of GPU companies all doing their own custom hardware. And you find out very quickly that doing custom hardware at scale is very different from showing us one chip. So I am excited for it, but also it's worth, again, being realistic and present to risks of taping out at scale, because that might involve experimental tape-out processes. It involves new architectures which are ever-changing. And this does not only apply to ASICs, it also applies to new kinds of GPUs, which are, for example, optimized for modular arithmetic instead of, U64 or U32, sorry.
Kind of going back to what we first started with the client side, server side, as far as I know, most of the hardware work is more focused on the server side. But you kind of hinted at like maybe there being sometimes something on a phone, or like, do you know of any client side hardware?
When I spoke with Omer from Guyama many years ago about him doing a snark ASIC company, that was his original vision, that Samsung eventually will, actually Justin showed that also on his slides, how you have a chip where the center 0.1 nanometer is the clear text compute or the untrusted compute, and its neighborhood of cells is the one that gives you the trusted compute out of it. I think that's a very exciting area. I don't think we are, it's going to take a while. Again,
no phone company is going to want to do that until we figure out those cool things around client-side proving where people are actually doing this on their devices. Then somebody is going to have to figure out a very hard problem of actually squeezing this thing on a computer like that you hold in your hand or utilize on your desktop or whatever. The demand's going to need to be there. You're going to need to see real applications and use cases and large relative compute workloads before somebody makes the investment to really add this stuff in. So that's probably, my guess is that's the
let's
last
figure out the
step.
application layer.
Yes.
And we can talk about, convincing Intel, next to the
do we really need them?
Yeah, and we're not going to hear the excuse of, we just need it to be really fast on the device and then everybody would use my thing. We hope some of this stuff is compelling prior to that in order to incentivize that performance to come online, if that's the last mile that we're going to get out of it.
The very simple way to see it is that an ASIC or a specialized piece of hardware that is not configurable at runtime, like an FPGA or a GPU, is a cost reduction method. You can get ASIC level performance by paying more. So again, let's not create narrative and let's be present to where we need to take the world.
I mean, back to our client side, server side, we were saying we have this distinction because the nature of the computation is very different. So if that is the case, do we really need specialized hardware on our phones if we already have this sort of, all right, I'll do a small, quick proof on my phone, send it out to be rolled up, and we're happy. Like,
it might be the case that, again, sorry, I said neural engine, it's a jargon, like vectorized compute units that you have on your mobile phone, they might be good enough.
Yeah.
You know, because it happens to be, actually, that I think that there's an interesting juxtaposition with machine learning here, where all of the Apple mobile devices are getting neural vector compute engines on them because machine learning is happening live on your phone. Now our phone is able to recognize my face, Alex's face, like, you know, without me doing anything. And how does it do that? What does machine learning reduce to? Well, it reduces to a lot of things, but like one big thing is the matrix multiplication. And the matrix multiplication has become something that happens a lot actually in hash-based snarks these days. So can we reuse the innovation frontier from the machine learning field to ZK? I think that's a very interesting question. I don't know the answer, but I think it's an interesting question.
Yeah. I wanted to have your guys' point of view on, I think there's a big dichotomy between the speed that we go at in the ZK space, in terms of software and in terms of research. We're going super fast. Like just a few years ago, we couldn't even envision having like a ZK VM. Like it was like, oh, it's impossible. It's just not performant enough. It would be way too slow. And now everybody does it. And so just in the span of a few years, and the dichotomy with that is like the speed of our hardware and research and actually the slowness of hardware. Like it's extremely slow to S-curve. Imagine hardware, like tape out hardware, like it's extremely expensive, it's extremely hard, and with many, many iterations. And the problem of that is that you're actually setting something in stone because you're actually making hardware, which is like not modifiable at this point when you tape it out and you send it to people. So do you think that is actually going to be really relevant if our research goes that fast? Maybe, oh, I make this hardware that is optimized for baby bear curve, and like tomorrow nobody uses it anymore because like there's something that is like 1,000x more performant that could come out like next week, literally. So I'm just curious about your point of view between this like.
You don't need to tape out. You can.
So how do you do software?
FPGA and GPU also exist.
Yeah.
FPGAs, GPUs. AMD Versal. There's tons of hardware out there built by people that frankly are way smarter than probably like the entire room together.
Ouch.
Well, no, it's just being realistic that they run trillion-dollar companies, and
I've just brought down the average. That's all. You guys are really smart.
You guys are great.
Yeah, everybody's great. Okay, pass. My point being is that like, okay, shit. The core point being that you don't need like to go all the way to the end to like say to someone that you have the optimal thing. You know, you are welcome to do iterations, and when you're happy with your thing and you have found that your thing actually has product market fit, you can take down the cost. It's a cost optimization technique.
So you still think there's like an avenue for ASICs? So because I see a lot of companies, for example, if you take Fabric, then their vision is more related to what they call, I think, a VPU, which is like a GPU optimized for things related to ZK. And on the other side, you have some companies that are on FPGAs, which are potentially less
not black or white.
performant, and other are like full ASIC, like want to optimize for this specific curve or something like that. So you think there's still an avenue for all of them in the future, or is it like, oh, we need to be general purpose, like more VPU?
It's dangerous to make predictions based on normative statements.
Especially about the future.
Yeah.
It's probably going to be heterogeneous in some different forms, and the mix will depend. I think Georgios' point, which I hadn't articulated this succinctly before, is look for the cost centers. Look for demand, where that demand is, and look for what are the big cost buckets. And I think if you look at it today, the common cost buckets across a lot of things are relating to these big data center-like applications, things like roll-ups and the like, and presumably the overlap is in that last mile.
The roll-up is a very high-margin business. Does the roll-up need to, halve its proving costs if it charges, whatever much? What percentage of the total cost actually is the roll-up proving cost? Is the roll-up proving cost actually maybe spent elsewhere? These are all questions that each company building hardware will need to pick its customer, understand their cost structure and their performance needs, and build accordingly. So again, like black and white thing is like extremely dangerous. And crypto loves to do that because crypto loves to do tribes and all of that. And I think you need to sit with that dissonance in your head and be able to understand that all of them could exist, just how NVIDIA exists and TSMC, and they're both massive businesses.
That's actually the only healthy equilibrium. If you look at the semiconductor industry, what's great about it is that you have multiple companies along the supply chain, all of which have healthy margins. And the thing that we have in crypto is a lot of people don't know where they're going to monetize and how, and so they encroach on each other's territory. It's why everybody tries to have a vertical proving marketplace and maybe wants to do their own VM, and maybe what about hardware? And when everybody's doing that, instead of specializing, it's part of an early market and uncertainty around business models, you don't get an equilibrium. So there's no good reason why NVIDIA would all of a sudden get into the fab business to eat into however much it's paying in margin to TSMC. There's no reason for that, because they get great service from it, they're not gouging them on price, there is an equilibrium there. And that's a healthy ecosystem. We are in a nascent ecosystem wherein people need to figure out what their business model is at different layers of the stack, which means we do need to figure out something for people in the hardware business. We need to figure out something on top of that in the maybe somewhere in the prover marketplace, the ZK11 side, so those people are nice and comfortable and have reasonable margins so that they continue to reinvest in their businesses on the client side and so forth. We don't have that today. And so you get the situation of either black and white, or everybody's doing a little bit of everything, just to make sure they have a call option on that being the valuable thing.
And again, crypto is in its, if not infancy, adolescent phase, and it's a bit, well, people just love to self-build everything, whereas you can always buy a solution because somebody else might be doing it better than you, and it might actually accelerate your time to go to market. But people, shipping product is a hard thing to convince yourself that you need to do sometimes in crypto, right? Because you can sell a token later. There's like a bunch of things that like convince you just, hey, I'll just keep working on infra and I will keep selling narratives to people. And I think there's a very toxic culture that exists in crypto that we need to delete from our brains.
Yeah, I keep wanting to be like, are we in crypto or are we in ZK?
There's a big sign in front of me saying crypto means cryptography, and I agree.
Yeah.
I admit that I use ZK in exchange for succinct proofs and all that stuff, even if it has no privacy.
Totally, of course crypto means cryptography. It is just the case that the customer is crypto companies that use cryptography as well, call it Web3, call it blockchain, call it whatever, and it is the case that there's warped incentives around them, and these inform the progress of the industry. So in the buy versus build conversation, in this early stage, I'm always buy, most of the times. Yeah, maybe other people disagree, but that's my general stance.
There's a question over there. He's been waiting patiently. Just press the red button. Or use a different one.
Hello? Yes.
There you go.
I'm super enjoying this. Thank you so much. This is just an input, so maybe you can talk about this. But when you mention GPUs, I'm over 30 years old. I used to have like a 3DFX Voodoo acceleration card. I cannot really understand that part of computing history without very strong monopolies. I mean, DirectX was extremely important to kind of fix that kind of stuff. So how would you add, because that's a big difference in terms of how it happened and how I believe we want it to happen now. So please talk.
That's actually a great example that I had read about recently, how, yes, indeed, DirectX was I don't know if people remember that, but like DirectX was like this driver that let you do graphics, I guess would be a way to put it. And it was a clear example of the commoditize your complement component where they made it very easy to like build on it and they abstract away things below that. Yeah, I think we're in this like very adolescent infant phase where things will change all the time, so it's a bit hard to tell. And I don't think I fully understood the question.
Does anyone else have a question? Oh yeah, did you want to grab a mic? Press the red button.
Hey, great panel so far. I really like open source software because you can audit it, you can look at it, you can see if it's safe. The thing about hardware is that you essentially have to trust whatever company is developing it. Is there a way to, independently audit hardware before you use it?
Wasn't this one of the very early ZK papers, like a 2013
Verifiable
paper?
ASICs?
Yeah, the verifiable
Global no
ASICs.
might have been.
Yeah,
What is it?
yeah.
What is it called?
Well, there was this like long
Verifiable
quip. There was a
ASICs.
great tweet that somebody had, maybe somebody in here, that was like, ZK doesn't need ASICs, ASICs need ZK, or something. That turned out to like age poorly as a take, at least so far, but maybe it's true. So ZK itself, you don't end up needing to trust that much from the sort of point from the prover. There's different, we say sort of the snarks, ZK, whatever space, we typically refer to very different properties, very broadly, right? So there's ones in which you don't trust the prover. There's other ones where, for instance, in privacy, you don't trust the verifier. And you're totally fine trusting the prover because you are the prover, right? And in those cases,
your hardware is the prover, and that's I guess the question. Your hardware is the prover, but I don't know if I can trust my hardware
well, right,
to not
you don't have
mess
your
up.
hardware manufacturer, right, of on your phone, right? And so in that setting, that's right. You would have to trust the hardware manufacturer in general, right? Which again, in an integrated manner, right? There's a lot of data on here that you might have to trust the manufacturer of anyway.
But
so
what does a backdoor prover do? It fails the verification. It cannot prove another statement.
No.
It has full access to your data.
Exactly. It leaks the witness.
It's at least the witness
Fully
information.
leaks the witness.
That's a problem.
Yes. But to answer your question, no, it's extremely hard. You can have things like sort of open sourcing the instruction set of a processor or open sourcing sort of the designs. But then what's actually printed on silicon, like it's extremely hard for us, the average Joe, to go in and see, like, am I really being sold what's on paper?
One area that is very important, it's not ZK per se and what we've been saying, but I'm sure everybody here is familiar with SGX or Amazon Nitro or heard of them. These are the kinds of hardware which create isolated memory and compute isolated memory regions and let you do the so-called trusted compute over various payloads. And they also let you produce a certificate, let's say that the compute was actually the right thing, which is actually very similar to how we use snarks as certificates of integrity. Trusted hardware or secure hardware, it's kind of like a misnomer to call it secure, evidently, because it's been broken 1,000 times. So trusted hardware is a famous area of research which has been traditionally very hard to do. It's been done inside the big companies, which are, again, way above my pay grade to audit. There was a great project a few years ago called, what was it called? Keystone Enclave. I believe the Berkeley research labs were doing it. I forget exactly who it was. It might have been Don Song. I forget, really. Which was basically an open source schema of a secure hardware example. So I would dig into that. And definitely open source, like everything that is like not trusted, so in the prover sense, for example, should be open source.
Is the certificate you mentioned something like, it's not a proof?
Definitely not.
Okay, yeah, it's like a transcript or?
The certificate that you get out of a GX is basically two things. It's saying it's a signature over the binary and the payload, so and the output. And you're assuming that I'm like killing this a bit, but like roughly what this means is that the verifier is expecting the secure processor to convince it that it ran a certain version of a binary with a certain payload, and if it actually ran that version of the binary, it outputted the correct thing. And how do you trust that signature? There is a process called remote attestation where you can call out to Intel or whoever the manufacturer is, and you can ask, hey, is the signature legit? Is this coming from a legit processor? Okay, Intel, thank you. Like, move on. This means that you're pushing up the trust to the hardware supplier, which may or may not be an acceptable security model for your, security model for your use case, I guess.
We are getting the signal that we are supposed to wrap this up. Also, we don't always do this at the summit, but this time around we're actually going to be having some drinks upstairs. So and it's already started? Okay, so we've already started the drinks. We're all late to the drinks. But yeah, thank you all to all the panelists. Thank you. Thank you for all these wonderful questions. Yeah, thank you for coming to ZK Summit 11 and being part of this event with us. I hope you'll join us for our next events. Should I say it? We know, actually. So ZK12, we already know, is going to be in Lisbon, October 8th. Okay. not announced anywhere but here. So this is the first time we're saying it, but we've actually booked it. So we're going back to Lisbon. We liked it so much, we want to do it again. I think I want to just mention ZK Hack Krakow once more if you weren't in the intro. This is going to be happening next month. It's a hackathon. If you want to build with ZK and you live around there, or if you want to just come join us, please do. Share this also with your colleagues if they're local. We'd love to, find out about more builders. And I just want to share one other event. I don't know if you guys remember the Web3 Summit that was in Berlin back in 2019. They're bringing it back. So if you'd like to join this is an event that's happening in August. Yes, and thank you again to the Web3 Summit for being one of our sponsors today. Thank you all. Cheers.